The VexIQ color sensor can provide color names, hue values, grayscale values, and even proximity values. The color sensor does this using 5 internal sensors that detect different wavelengths of light. When the color sensor is set to detect color and hue, it uses a series of 3 of the internal sensors, one each for the red, green, and blue wavelengths of light. Ambient light from the robot's environment reflects off of objects and surfaces near the color sensor and reaches the sensors. The VexIQ color sensor combines the readings it gets from them and generates a hue value ranging from 0 to 255, which corresponds to a range of colors. The exact hue values for pure red, green, and blue are 0, 85, and 171. So if the color sensor has a hue reading of 0, we know that it's seeing a red object. Other colors fall somewhere between the red, green, and blue hue values. For example, the color yellow is a mixture of the colors red and green. So its hue value falls in between red and green, with a hue value of around 42. In Robot C, you are able to use the color sensor's hue values directly in your program, or more accessible color names like color red and color blue, which are associated with ranges of hue values. Keep in mind that the color sensor's readings depend on the ambient lighting in the robot's environment. This means your sensor readings may change if your lighting conditions change, so be sure to test your programs in any new environment. The grayscale values from the color sensor are useful when the robot needs to detect the difference between dark and light-colored surfaces, such as when it needs to track a line. In grayscale mode, the color sensor shines a white LED and measures the amount of reflected light with a 4th internal sensor that detects the brightness of the light. The reflected light is converted into a value for you to use in your programs. When the sensor is pointed at a dark-colored surface, more of the light is absorbed by the surface, and the sensor will return a low value. When the sensor is pointed at a light-colored surface, more of the light is reflected back to the sensor, so it will return a high value. The 5th internal sensor in the color sensor is an infrared emitter and receiver. The infrared emitter sends out a beam of invisible infrared light, and the receiver measures how much is reflected back. Objects that are close to the sensor reflect a large amount of infrared light back to the sensor, resulting in a high sensor value. Objects that are further away reflect less infrared light back to the sensor, and result in a lower sensor reading. The proximity values do not correspond with a set of units. But by understanding that large values indicate a nearby object, while low values indicate a faraway object, you can determine when an object is near your color sensor.